Okay. Hey guys, we are getting ready to take our stoichiometry test here in the next couple of days, and I want to make sure that you have some resources to help you just in case there are any kinds of confusion. All right, so I want to go back though. Last unit we did mole conversion, and I want to make sure that you understand what you did or what you were doing when you were doing mole conversion. Okay, so let's go ahead and start with looking at how we were doing our conversions. That sounded redundant. Anyways, okay, so we always start, or we don't always start with grams, but we start with grams and then we convert to moles and then we can convert to particles. All right, I cannot, let's just make this clear. I cannot convert grams to particles without converting moles. So the only way to get from grams to particles is at some point calculating moles. How do we do that? Okay, so here we go. All right, so the conversion, if your known unit from the problem is coming from grams, I need to convert to moles. So how do I do that? You can think of it like this. If I told you I had 144 cookies and I want to know how many dozens that is, what do I need to know about dozens in order to make that conversion? I need to know that there are 12 cookies in a dozen, right? Well, in order to figure out how many grams are in a mole, you have to calculate the molar mass of that compound. And we do that by dividing by molar mass. You might also hear formula mass as another term. Same thing for our purposes. So we will divide by molar mass, our grams, to convert to moles. What if I had moles and wanted to know, well, how many grams is that? What would I need to do then? In this case, I need to multiply by molar mass. All right, are you with me? Okay. So to get from grams to moles, we have to divide by molar mass. To get from moles to grams, we have to multiply by molar mass. All right, now, if I needed to get from moles to particles, there's a certain number I need to know, and that number would be Avogadro's number. So here, I'm going to be using 6.02 times 10 to the 23rd. And it could be particles, molecules, ions. It could be many things. Just like you can have a dozen basketballs, you can have a dozen cookies, you could have a dozen of anything, right? So anytime you hear molecules, particles, atoms, whatever, it's referring to the same conversion unit using Avogadro's number. All right. Here in this case, if I wanted to know how many particles are in a mole, I need to multiply by Avogadro's number. All right. If it's giving me particles and I didn't know how many moles that is, in this case, I need to divide by Avogadro's number. I'm showing you this just to give you another visual of what you're converting to and from. Remember that all of this can be reversed. It can go this way. Okay? So that's why you have the arrows going in both directions, from here to here, here to here, and then opposite. And notice the patterns. Okay, if I had particles and I start on this end, well then I divide first and then multiply by the molar mass. If I'm starting over here at this end, I divide first by molar mass and then multiply by Avogadro's number to figure out particles. The patterns in science are essential. Patterns in science and math are essential to helping you be able to put these puzzle pieces together, because essentially really that's what it is. You're putting puzzle pieces together, what you're learning in science and what you're learning in math, and you're starting to apply all of these little concepts together. And it makes it, I'm telling you, it makes it so much easier when you can see the patterns. All right, so how is this all relative to, let me see if I can group this together. How is this all relative then? Oh no, that's not what I wanted to do, sorry. How is this relative to our conversion in stoich? There we go. All right, I'm going to leave this somewhat here, and I'm going to pull this chart because this is this is what we're doing in stoich, and I want to refer to a couple of things here. All right, so this we were looking at when we're doing basic mole conversion, but this still applies to what we're doing in stoich. Here, however, I want to point out to you, when you go, when you are going from the moles of the reactants to the moles of the product, what number do you need? Well, what's not listed here that it should say is that you need that mole ratio. And the mole ratio comes from the coefficients in your balanced chemical equation. That's what we've been talking about. Has nothing to do with subscripts. This is all coefficients. Mole ratio gets you from the mole of the reactants to the moles of the products. So in your conversion, as soon as you get your conversion to moles, whether you're going from grams to moles or particle to moles, as soon as you get that moles of your known, then in your equation you would put mole ratio, and that conversion will help you get to your products, and then you can solve from that point on.